From San Francisco's Golden Gate Bridge, you throw a heavy rock upwards with an initial speed of 2 meters per second. When does it hit the water? 77 meters below. Let's go ahead and extract the essential information from our problem. We are told it's a heavy rock. We can ignore air resistance. We're launching upwards with an initial speed of 2 meters per second. So our initial velocity is plus 2 meters per second. 77 meters below, our delta x is negative 77 meters. We are defining up to be positive. San Francisco is on the planet Earth. Therefore, the acceleration is equal to the acceleration of gravity, negative 9.8 meters per second squared. Again, we're calling positive upwards, so the acceleration here is negative. And the problem is asking, when does the rock hit the water? So here is our relevant equation. Delta x is equal to v naught delta t plus 1/2 a delta t squared. Now in this case we know delta x, we know v naught, we know a. What we don't know is delta t. And delta t appears in two places, delta t squared. So in other words, we have a quadratic equation, and we're going to need the quadratic formula to solve for delta t. So I'm going to go ahead and do something I don't normally advise. I'm going to go ahead and plug in the numbers and then do the algebra. So we have our delta x is negative 77, and I'm also going to leave off the units just so to save space on the paper here, is equal to v naught 2 delta t plus 1/2 a, I'm going to go ahead and call that negative 4.9 delta t squared. Now in the quadratic formula, we normally have it in the form of ax squared plus bx plus c equals 0. I'm going to go ahead and bring the t squared over to the other side and the t over to the other side, and so we're going to have 4.9 delta t squared minus 2 delta t minus 77 is equal to 0. Our 4.9 is a. Our negative 2 is b. Negative 77 is c. In the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative b, negative negative 2, gives us 2 plus or minus the square root. B squared, negative 2 squared is 4, minus 4 times 4.9 times negative 77, all over 2 times 4.9, so all over 9.8. First I'm going to calculate what's in the radical here. We have 4 times 4.9 times 77 negative gives us negative 1500 or so. We are subtracting that from 4. That gives us 1513. We're going to take the square root of that, and that gives us 38.9 or so. So we have 2 plus or minus 38.9 all over 9.8. So we have 40.9 over 9.8, or negative 36.9 over 9.8. Now, the negative time here doesn't make a whole lot of sense because that is in the past. We're looking for the time after we drop the ball. So we're simply going to cross that out and not consider that. So now we take our 40.9 divided by 9.8 equals 4.17. Now we had two significant figures at the beginning, so I'm going to call that 4.2 seconds. The rock hits the water 4.2 seconds after we threw it. And now our question is, how fast does the rock move as it's hitting the water? What's its speed at that moment? We're going to use our equation. Delta V is equal to A times delta T. And this is 4.2 seconds after being thrown. Our acceleration is negative 9.8 meters per second. The velocity decreases 9.8 meters per second every second it's in the air. And it's been in the air 4.2 seconds. So we get out our trusty calculator, and we have negative 9.8 times 4.2, negative 41, 2 sig figs, meters per second. Second here cancels the square on the bottom, and we're left with meters per second as our change in velocity. Now, the final velocity is equal to the initial velocity plus the change in the velocity. 2 meters per second plus a change of negative 41 meters per second. The rock is moving downwards at 39 meters per second as it hits the water.